Today we're going to look at creating the models ourselves, that is making the equations based on properties or pictures or tables or other information. Our objective is to build that equation that we need that represents the model that we want. Following this lesson would be the mid-chapter assignment. Basically goes through everything we've done so far in this unit. There's only one lesson left after that before you do the review, so you might want to start thinking about your test and when you want to do that. For every model that we build, every equation that we need, and remember an equation would be in the form y equals a sine or cos, let's just call it sine for now, k x minus d plus c. We're going to need four things, the a, the k, the d, and the c. Now, all four aren't necessarily used in every equation. There might not be a phase shift, for example, or there might not be a vertical translation. But you still need to figure out your amplitude and period every time. So back to the beginning of this unit, we talked about the amplitude is your max minus min divided by 2. Your vertical translation, your c, would be max plus min divided by 2. We've been using the equation period equals 360 over k repeatedly. That was kind of handy. Something else kind of nice about periodic curves, if you know your max and you know your min, let's say we know those two things, well, you know that's actually half a cycle. So if these two things were, let's say, 30 degrees apart, well, the rest of it would be 30 more degrees. So the period would be 60 degrees for that. So knowing the difference between a max and a min and how far apart they are will give you the period. And the tricky one, we'll put a star down on this next to the bottom here, will be our horizontal translation. We did this when we made equations for horizontal ones, but just a couple reminders. A cos curve should always start the maximum and go downwards. So if this is my graph, and my cos curve is over here, it means I've had a phase shift to the right, because it's supposed to be right here. If it was a sine curves are supposed to start on the central axis and go upwards. Okay? If I notice my central axis is over here, though, and going upwards, that means I've had a phase shift. Okay, so we'll come back to those two again when we start looking at some equations. But that's probably the two trickiest parts. My preference is to make a cos curve every time because it's easy to find a maximum. Okay, I want to make an equation that has these properties. Okay, so if we call the first one here letter A, okay, I'm going to start filling the parts and pieces that I need. Remember our objective, y equals a sine or cos k times x minus d plus c. You might not have all the parts and pieces, but you got to take a look at which ones you do have. So our first one, y, equals the amplitude, a. Oh, I've been told it's 0.8, so I can fill it in. I've also been told it's a sine curve. K, well, I don't know k, but I know the period is 720. And we said you can find k by taking 360 and dividing it by the period. In our case, 360 over 720, which is 1/2, or 0.5. And I don't care if you use a fraction or decimal. Either one works. So 1/2, bracket, x. Okay, it tells us there's a phase shift left 45. Okay, remember with phase shifts, we go the opposite direction when we go in and out of that bracket. So a left suggests it's a subtracting, which means in the bracket it's actually an adding. It does the opposite. Okay, and our central axis is y equals 3, so we need a plus 3 at the end. Okay, and there's equation A. If I do the same thing with B, you guys give it a try, see what you can do. Y equals 2 cos k. I'm going to do that over to the side here. K equals 360 divided by the period. Period is 60. Gives me 6. And there is no, oh sorry, there's a right 120. So right means I have to the opposite, so subtract. And the central axis, it says none, but that just means it hasn't been moved. So there is no part at the end over there. It's a regular old central axis. Okay, and there's the equation for that curve. So our objective today when we come across things is basically to make this table, right? We want to find the amplitude, the period, the axis, and the phase shift. If we can identify those four things, we can fill them in pretty quickly. Okay, so let's take a look at a picture. I want to determine two different equations for the given graph. So I'm going to start with the easiest things I can find. I'm going to find A. A equals max minus min divided by 2. What's the max? Well, it's 3. The min, -1. Divided by 2, I'll get 4 over 2, which is 2. The next easiest thing to find is the C value. Max plus min divided by 2. Our average. So 3 plus -1 divided by 2 is 2 over 2, which is 1. Okay, I'm going to look for my K next. To find the K, I need to know the period. And I can tell from this graph, 30 to 90 is half of a cycle. So to complete the cycle, I have to go back to a max. If this is 60, then this is 60. So the period has to be 120. To find K, I take 360 and I divide by the 120, the period, and I get 3. Okay, so I've got 3 of the 4 parts. The only part I need, the last part, is a phase shift. I'll figure that out in just a second here. So y equals 2. I'm going to choose a cos curve. That's my prerogative. I can choose whichever one I want to. I think cos curves are the easiest ones to figure out, though, so that's why I'm going to use that one. I'll explain why in just a second. 3 is my K value. The phase shift. Well, we know the very first point is supposed to start at the maximum and be right here on the axis. Ours is not. It's been shifted 30 degrees to the right. So how do I show that? Well, x minus 30, opposite sign, right? And in my central axis, plus 1. Just to go back to why I chose a cos instead of a sine curve, cos curves start on the maximums. They're easy to find. I can look at the picture and really quickly notice where a maximum is, as opposed to a central axis. It's a little bit more challenging to find. Okay, not something often labeled on a diagram. Okay, the question asked us to find 2 different equations for the given graph. Well, how can I find the second one? Well, I could take a lot of the same things, because the amplitude's the same, the period's the same, the central axis is the same, and choose a different phase shift. Okay, let's say I wanted to say, oh, it's not starting at 30 and 3. No, I'm going to start my graph here, at this point. Well, can I figure that point out? Sure I could. My period's 120, which means this point is 120 past 30. That makes it 150, right? So a second equation could be x minus 150. A different phase shift, but the same property still. If I didn't like that one, I could have gone backwards and said, oh, I want to use this one. What's 120 degrees before 30? Well, that's negative 90 and 3. So a third one I could have said is y equals 2 cos 3. We're 90 before the axis now, so to the left. So to show that, put plus 90 in, plus 1. Okay, so I can make all kinds of equations. I'm just going to pick different phase shifts. That's all I really need to do there. And that takes us to the end of the first page.